All right, guys. So today comes from our calculus textbook. We are learning 5.4 and 5.5 together. The reason why I combine these, 5.4 is e to the u, and 5.5 is a to the u, both the integration. I combine them because the rules are so similar. Remember, technically, you only need to learn this bottom one, because if I applied e as this number base, then I would just have ln of e down here, which ln of e is 1, which makes the denominator disappear, and that's how we get this top formula. Okay, so I do put them both. I like memorizing them both myself. So every single one of these questions is going to be a u substitution question, which we learned last chapter. Okay, and for I'd say about 95% of these questions, especially the simpler ones, the exponent is always your u. So if you can use the play on words, the exponent is always the u in an exponential function. Make sense? All right. So let's look at these two examples. For this first one on slide 3, who is my u? 3x plus 1. What is the derivative of 3x plus 1? 3. Am I missing anything in this problem? So this is my u. My du3 needs to exist there. So I am missing that 3. Right. So I put the 3 in the inside, and like you said, the 1/3 on the outside. The reciprocal. Exactly. Okay. So now this guy up here is my u, and the 3 is my du. So now I'm rewriting. I'm saying 1/3 times the integral. The 3 becomes your du on the outside. And then I can rewrite this as e to the u. So finish writing it in terms of u. Now, once I get it down to e to the u, which if you do these questions right and you do all of this cleaning correctly, you should always end up with just a simple e to the u. Maybe some coefficient in the front, but just e to the u. And now I can go to my formula. The antiderivative of e to the u is just e to the u plus c. So I bring down that 1/3. And now my last step is just to fill in that u back to x's. So I have 1/3 e raised to 3x plus 1 plus c. And I'm done with that one. So our next question. Who is our u? Negative x squared. Good. What is the derivative of negative x squared? Negative 2x. Okay. So if we look at the original problem, we have the x. That part's good. But I'm missing this negative 2. So I need to multiply in a negative 2, which means on the outside I need to multiply a negative 1/2. But what about this extra 5 here? What would we do with extra coefficients? I could take it right out here. Okay? Extra coefficients, you can move them out of your way, take them outside of the question. So now on the outside, I have negative 5 over 2. Okay? The 5 moved, so he's no longer there. The negative 2x is my du. And now I write e to the u. So again, if you did everything right, you should just have an integral of e to the u. Drop the negative 5 over 2. Antiderivative of e to the u is e to the u plus c. Bring down that u. And I have negative 5 over 2. E raised to negative x squared plus c. And you're done. So here's one option for the answer. If you plan on taking AP, in AP they do not accept negative exponents. So you could also write this as negative 5 over 2. The negative exponent just brings it down to the denominator. So I'd have 1 over e to the x squared plus c. But again, this is something I really only enforce in my AP classes. If you plan on taking it next year, it's a good habit to get. All right, so let's look at slide 5. We have two questions. The first one reads the integral of e raised to 1 over x divided by x squared. Who is my u here? Nice, 1 over x. What might be an easier way to see 1 over x? Nice, x to the negative first. What is the derivative of that? Derivative. So we multiply, remember, to the front, -1, and subtract 1. Okay? Another way you might be able to spot this is -1 over x squared. Do any of you wish to rewrite the original question? How? Good. You are allowed to bring that x squared up. You don't have to. If you spot it here that the x squared should be in a denominator, then you don't have to rewrite it. But if you stopped here, you might want to rewrite the question. Okay? So just an option is to rewrite e raised to x to the negative first. Oh, I wrote it wrong. Hold on. Pause. So e times x to the negative first times x to the negative second. We see that? So now it might be a little easier for some of your eyes to see the u here and the du there. Is anything missing from my du? The negative sign. So you could put the negative here and then put 1 on the outside. So now my rewrite should be a negative integral of e to the u, and this becomes du. Okay? Bring down the negative. Antiderivative of e to the u is e to the u. And then bring your u back down. So negative e raised to 1 over x plus c. Okay? Any questions on this one? All right, next question. Who is my u? Nice. U is cosine of x. What is the derivative? Nice. You didn't miss the negative. So here's my u. And here, do I have a problem? Nice. So my rewrite, I bring down that negative integral. This negative sign of x becomes my du. And then I write e to the u. Easy antiderivative. And then plug that c right back in. Yes, I'm sorry. I meant plug that u back in. Thank you. You're done with that problem. So now we're going to see some definite integrals. Okay? So we're going to start off the same. For this question on letter A, who is my u? Good. And the derivative of that is? Good. So the reminder that you need to give yourself during these questions is that in u sub, in definite integrals, you need to rename your A and your B. I do that by plugging those two numbers into my u. So I say u of 1 is me plugging 1 into here, which gives me -1, right? And then I plug 0 into that function, which gives me 0. So now, back to my u sub, I have the negative x there. Am I missing anything with my du? I'm missing, good. I'm missing this negative, so I have to put a negative and a negative. Okay? So drop that negative down. The integral from my new a to b, and then just e to the u, du. Antiderivative of e to the u is simply e to the u. I do not plug the function back into u once I've changed my a and u. Okay? So now I can say, I leave the negative outside, e to the negative first, minus e to the 0. Okay? What do you think your multiple choice option would say? negative. That negative exponent drops it down to the denominator. Negative and negative make plus. And what is anything raised to 0? 1. Yep. And you are done with that problem. Now, the next two questions are not going to be as simple as identifying the exponent as the u. These are what I would consider two of the more confusing questions for today. Okay? So, if I use the method of picking the exponent as my u, look at letter B. That would mean I pick x as my u, and du would be 1. If that were the case, I have way too much going on that's extra. I have an entire 1 plus e to the x. Okay? So then the next question, I'm going to address one at a time. The next question is picking e to the x as my u. Derivative of e to the x is e to the x, but then I have a plus 1 as extra. Okay? So last option would be to pick this entire denominator as my u. Okay? Don't be afraid if you find yourself doing a little bit of process of elimination. Okay? So if I pick the entire denominator, the good thing about picking this denominator is what's the derivative of 1? Right, it's 0 plus derivative of e to the x is e to the x. So in my denominator, I have my u, and then in my numerator, I have my du. We see that? So I'm going to do my new a and b in a moment. But know that we're going to be writing the integral of du over u. All right, so now I'm going to find my new a and b. So I'm going to find u at 1. So if I plug 1 into here, don't be afraid of this, but it's literally 1 plus e to the first, which is just e. Okay, so that could be my new top limit. And then if I plug 0 in, I have 1 plus e to the 0. What is e to the 0? 1. So 1 plus 1 is 2. Who can remember what the antiderivative of du over u is? U prime over u, which is? Good, it's the ln. From 5.2 from last class, it's the integral of u prime over u is ln of u. Okay? So now, I'm going to say the answer to this is ln of u from 2 to 1 plus e. And again, don't be afraid of this just because it looks ugly. You can leave this as ln of 1 plus e minus ln of 2. All right, so for this next one, I have e to the x times cosine of e to the x. Who can figure out what our u is supposed to be here? Which one? The one on the outside or the one on the inside? Nice. So remember last class, the review that we did for last chapter, we talked that when we see trig functions, the inside of that trig function is usually our u. So what is the derivative of e to the x? E to the x, which is nice. I have it right here. So this one is my u, and this one is my du. Okay? I'm going to be rewriting the integral of cosine of u du. Yes, we have to find u, a, and b. So I'm going to plug in 0, and then I'm going to plug in negative 1. So e to 0 is 1. And then putting in a negative 1, e to the negative 1, 1 over e. Beautiful. Antiderivative of cosine. Just positive sign. Remember with integrals, if the answer has a c, that's when you give the negative. So I have a positive sine of u from 1 over e to 1. And now sine of 1 minus sine of 1 over e. So we're going to start working on questions of a to the u. Remember, a just represents any number other than e. Okay? In this first question, we're going to see such a simple question that u sub isn't even needed. I'm going to write it because I'd rather you play it safe and use u sub when you don't need it. It'll still give you the right answer versus forgetting it when you do need it. Okay? So if I was thinking u sub, who would my u be here? X, right. U would just be x. And then derivative of x is 1. Anytime on a u sub that you get x and 1, you know you didn't need it. Okay? Let's say I do finish it with u sub. I say the integral from 2 to u, of 2 to the u du. And based on the antiderivative that we wrote on our first page, we are now looking at this rule. A to the u is a to the u and then over ln of a, which is at base. Okay? So we have 2 to the u over ln of 2 plus c, and then we put that u back in. And we have 2 to the x over ln of 2 plus c. So again, if you realize that you do not need u sub, okay, I'm going to put my fingers on this part. You can say, I don't need u sub here, so the answer to this is just itself, 2 to the x over ln of the base, which is 2 plus c. So if you can catch you don't need u sub, you can go straight to that step. On question number 9, who is your u? Negative x. The derivative of that is? Do I need u sub here? Yep. So I have my u. Do I have my du? Nope, I'm missing that negative. Okay? So I can bring down the negative integral of 5 to the u du. Bring down the negative. Antiderivative is 5 to the u over ln of 5 plus c. And then just plug that back in. So this is an acceptable answer, but again, if you are considering taking AP or are currently taking AP, they do not allow negative exponents. So this 5 raised to the negative x would just drop down to the denominator. And I'd leave a 1 in the numerator. So for this next question on slide 9, do you guys see that it's 2 different terms separated by addition? Remember, you don't necessarily need to write it out, but remember that when they're separated by addition or subtraction, you can solve each individually. Okay? What type of question is this first one on the left? Is it an e to the u or an a to the u? Remember, exponential functions have the function in the exponent. This is them trying to throw you off. This is not even an exponential function. This is just a simple reverse power rule. You see how here the function is in the exponent and here the function is in the base? This is just a simple reverse power rule. So add 1, you get x to the 4th, and divide by your new exponent. I'm not going to put the plus c yet. I'm going to put it at the very end. I'm just going to keep working with this problem, and then I'll bring this guy down. Now, this next one on the right side is an exponential function because the function is in the exponent. Who is my u? Good, negative x. The derivative of that is negative 1. Am I missing anything? Good, I'm missing that negative, okay? So, good. Instead, I'm going to subtract. So I'm going to have a minus integral of 3 to the u du. And I'll end up bringing this guy down in a moment. Antiderivative of e to the u, excuse me, of a to the u is to rewrite over ln of that base, which is 3. So now our next step is to bring that u back in. And I have negative 3 to the negative x over ln of 3 plus c. I need to bring this guy down and say 1 over 4 x to the 4th. And again, remember, if you are in AP or planning on taking AP, they do not allow negative exponents. So I would change that 3 to the x down to the denominator, leave a 1 in the numerator. And that would be my final answer there. All right, for this next one, what do you think my u is? Nice. Again, it's an exponential function, so the exponent is my u. What is the derivative of that? 2 times 3 minus x. Yes, thank you. Times negative 1. So, a heads up, if you ever plan on taking AP, this is a question they would consider an easy, quick one. Okay? It's not even definite. But I promise you, even though it's a level easy question, a large majority get this question wrong because on their u-sub, they forget the chain rule. And I promise you that the answer without this negative 1 is one of the options in the multiple choice. Okay? So just a heads up. So I have the 3 minus x. What am I missing? Good. I'm missing that negative 2. So I need to put in a negative 2 here. And what do I need to put on the outside? A negative 1/2. Okay? All right, so now we're going to our rewrite. We have negative 1/2 integral. This entire portion is now my du. So I'm going to write the du at the back. And now I'm left with 7 raised to, remember that entire exponent was my u. Okay? And now comes the easy part. Negative 1/2. And then the antiderivative of this is rewrite over ln of the base plus c. Okay? So that's a correct answer once I plug in this u. But don't be surprised if they also combine this 1/2. It is multiplication. So I have negative 7 raised to that 3 minus x squared. All over, the 2 is going to get multiplied with that ln of 7 plus c. For this next question, who do you think my u is? Nice, sine of x. What is the derivative of sine? Be careful, we're on derivatives. Just cosine. In derivatives, if the question has a c, your answer gets a negative. So am I missing anything for this one? Nope, I've got my u up here and my du down here. This is a perfect question. So I have 2 to the u du. Antiderivative is rewrite over ln of the base plus c. And then lastly, plug that u back in. 2 raised to sine of x over ln of 2 plus c. All right, let's finish off with these last 2 questions. These are a to the u questions, and they are definite integrals. So for this first one, who is my u? x over 2. What might be an easier way to see that? No, so think of it, I always think of food. Think of pizza. If I say pizza divided by 2, it's half of my pizza, right? So same thing with x's. Whenever you just see a number in the denominator, it can be brought out as a fraction. What is the derivative of half times x? Just half. All right, so do I have my du there? No, I need to multiply this half, okay? Remember that this does not affect my 4. My 4 is not a coefficient. My 4 is a base to that function. So if I had to put a 1/2 in, I have to put a 2 in, okay? So now my rewrite becomes 2 times the integral. I'm going to have to change my limits in a moment. Of 4 raised to the u du. So now we plug in my a and my b. Okay? I'm plugging it into my u, whichever one makes you happy. So half of 2 or 2 divided by 2 is 1. Good. And negative 2 divided by 2 is negative 1. Good. Bring down that 2. Antiderivative is a rewrite over ln of the base. When I've changed my limits, I do not need to plug my x back in. And then I just do my f of b minus f of a. Don't be surprised if you see this 4 to the negative 1 because it's a negative exponent be brought down. But other than that, you can leave this as is. All right, our last question for today. Again, 2 terms separated by subtraction. You have the freedom to rewrite and solve each one at a time. For good notation, don't forget to write that dx after each question. So for this first one, who is my u? And my du would be? Do I need to do u sub on this question? No, very good. So what would the antiderivative be of this first one? Good, my rewrite over ln of the base. And the second one would be? Good, 2 to the x over ln of the base. Okay? And this goes from 1 to e. Oh, we've got a little buddy here. You see him? We'll let him be. He's our class pet. All right, so now I can just do my f of b minus f of a for each. 6 to the e over ln of 6 minus 6 to the first over ln of 6 minus 2 to the e over ln of 2 minus 2 to the first over ln of 2. Now, this can get cleaned further along by distributing the negatives and combining like terms based on the denominator, but I would suggest, especially if you're in AP, to stop here. Remember, on an FRQ, once you are done with f of b minus f of a, you do get full credit. And I've had students in the past who do this correctly, but then when they go to distribute the negatives, they literally mess up just because of a sign. So be very careful, okay?